Have you ever tried to locate a tiny, elusive insect in a dark room using a flashlight? The very act of shining the light might disturb it, making it harder to pin down its exact spot or predict its next move. Now, imagine this on an incredibly tiny, fundamental level, where the act of shining a light is not just disruptive, but inextricably linked to what you are trying to measure. At the subatomic scale, we cannot know a particle's exact position and its exact momentum simultaneously. This profound concept is known as the Heisenberg Uncertainty Principle, and it is not a limitation of our technology or our ability to measure, but rather a fundamental, inherent property of the universe itself. The reason for this lies in the strange nature of subatomic particles. Unlike the objects we see in our everyday lives, which behave like tiny solid balls, particles like electrons and photons also behave like waves. When we try to determine a particle's position, we are essentially trying to pinpoint a specific point within that wave. To do this very precisely, we need to use a very short, localized wave. However, a short wave is made up of many different wavelengths superimposed together, and wavelength is directly related to a particle's momentum. The more precisely we define its position, the less precisely we know its momentum, because we have a wide range of wavelengths involved. Conversely, if we want to know a particle's momentum very precisely, we need a long, pure wave with a single, well-defined wavelength. But a long, pure wave is spread out over a large area, meaning the particle's position becomes very uncertain. This means that in the quantum realm, we cannot simply observe particles without affecting them. Any attempt to measure one property, like position, will inevitably disturb the other property, momentum, in a way that makes it less certain. Scientists therefore work with probabilities and distributions rather than precise values, understanding that this inherent fuzziness is a core feature of reality at its most basic level. This isn't just a quirky theoretical idea. It is a cornerstone of quantum mechanics, the theory that describes how the universe works on the smallest scales. It explains why atoms do not collapse, why elements have their specific properties, and underpins technologies from lasers to modern electronics. Understanding this principle helps us grasp the truly counterintuitive nature of the quantum world, where certainty is often replaced by probability. The Heisenberg Uncertainty Principle reveals that the very fabric of existence at the subatomic level is inherently probabilistic and dynamic. It teaches us that there is a fundamental limit to what we can simultaneously know about a particle state, reminding us that reality is far stranger and more fascinating than our everyday intuition might suggest.